You're working on KIT Tracker, and it's coming from the Center for Disease Control. And what we need to do is try to track the medical kits that organizations send in a disaster response and send to places like refugee camps. What we need to do is figure out a way to track that along the way so it doesn't get lost, that the goods don't get spoiled, that people know what's coming, and that people can get the goods and bring it to where it is needed. So what we're doing is trying to figure out the actual tracking system to be able to grab the data about where it's going, and then also to create a database to put the information together to know what's there and what's needed where.
And how far did you get today?
Well, in this case, because of the context, we wanted to do a lot of research because I think it's a very particular situation, especially on the ground. Thankfully, some people in our group have connections with humanitarian organizations, and we have some guests here today who are able to help us and give their actually firsthand knowledge of how the system actually works on the ground. So from point to point, where the box is going, what's happening, who has to look at them, and what's the most practical way to actually know where these boxes are going. So we had to do quite a bit of talking before we're on it, but we're actually getting onto the actual system now, which is great, and we actually feel very confident about it because we have all this information.
Excellent. What project are you working on?
We're working on a wound classification system. The objective of it is to be used in refugee camps after a disaster or war. And the idea of it is you have volunteers walking around with smartphones and taking pictures of patients' wounds. Once that picture is taken, you send it through MMS with adding additional demographic information about the patient, such as the name, gender, age, and the location of the wound. So you add that as text along with the picture, and you send it in an MMS to a central server. Now, once it's received at the server will assign it to an ID that will be sent back as an SMS to the volunteer. That number will be given to the patient in order to be used during the follow-up. Now, on the server side, once the image is received, the dimensions of the wound are calculated. So we're talking about the height and the width, and also we'll calculate the estimated time for the wound to heal. All that information, once it's calculated, it is available in a queue for the physicians. So the physicians remotely are reviewing this information. They're looking at the picture, they're looking at the information, they can update the estimated time to heal, and also classify the wound, so what type of wound it is, and the severity of it as well. Now, assuming it's a high severity classified by the physician, an SMS will be sent automatically to the volunteer informing them that for this patient, the wound is of high severity and the patient should seek medical attention right away. So this will streamline the process of classifying the wounds and of triaging as well. And once the patient comes to see the physician will have all that information available. The patient will provide them with the reference number that was provided earlier. The physician will stitch the wound and record in the system when he or she wants to see the patient next. And basically, that's the idea of the app.
Hi, I'm working on the not far from the tree project. It's an initiative here in Toronto about getting the best use of the harvest of trees that have fruit around Toronto, and being able to share it with among the volunteers and the food banks, as well as from the tree owners themselves. What we've done right now is the initiative has already been around since 2008, and we're trying to get it up online by having a map that's accessible to everybody to find out where there are trees available with fruit that volunteers can harvest. So what we want to do right now is get the database up and link that up with the mapping, and also have an interface system where people can submit the trees that are available, that they know of, that might be public or that belongs to a tree owner, and make that information available, as well as for people to submit the information and also access that information maybe for food banks to be able to submit the request to have some of the harvest from those trees.
So what kind of programming is going on? What kind of languages and systems?
Well, so we've done we've assessed Ushahidi as a platform for the database linking, as well as for the interface. So we're working with that right now. We're customizing it. We've done the default install, and so right now we're working on the add-on Also, Laura, who is the founder of the Not Far From the Tree project, was here as well, and so we found out a bit about her user requirements with the volunteers need from the system, as well as hers with the organization, as well as the visitors at the site. So we're thinking Ushahidi might be the best platform to use to be able to manage that information, present that information on a website using PHP as the coding base for presenting the information online.
Cool.
What we are trying to do is we are trying to get our heads around how to bring amateur radio in as an extra data source and a resource for the likes of Ushahidi and Suhana and these other disaster management tools. I mean, the amateur radio community is accustomed to helping and assisting coordinate and aid when it comes to disaster relief. I mean, they've been around long before the internet was here, and they might well be around after the internet is gone. You know, so basically what we're trying to figure out is how do people who've got reliable but low bandwidth communication tools can assist.
And how's the progress going?
Well, at the moment we are, on some levels, it is an absolutely vast problem, and we're just trying to get our head around the issues, and we're trying to get our head around, what tools and resources are already available that we can exploit, and going from there.
Excellent. Thanks.
So, the application we're working on is the message passing one, and the scenario is, say you're in a community or you're in some place and a disaster happens, and all of the cell towers go out and all of the internet connection goes out, and you're really unwired and you've got no connection to the outside world anymore. You want to still get your messages out, your smartphone still works, and the issue is you just don't have any cell access or any connection to the outside world, to the internet. And so the idea is, in an ad hoc way, when you pass somebody else who has the same sort of services running on their cell phone, messages that you want to get out will be passed along to these other people, and their messages will be passed along to you. And so eventually the messages will disseminate from person to person, from phone to phone, and eventually somebody with a stack of messages will get to an internet connection and finally be able to unload their payload to a central server, which will be able to take all of those messages, and if it's meant for an SMS, it will send it through a Twilio service to the right person as an SMS. If it's an email, it'll send an email to the right person as an email. If it's just an open-ended message, like a broadcast, and it happens to be part of a disaster zone, then it will be sent to the Suhana server that's handling that, and use the person finder API and go up and say, if need be, that you are possibly a missing person, but you're okay, and this is your location, and this is the time that you sent that message. And so all of these things will sort of be incorporated and passed along and out of these dark zones in an ad hoc manner.
So what were the biggest challenges in wrapping your head around this?
So the biggest challenge is the technical one, and still remains the biggest challenge, is how you get the phones to communicate with one another. Bluetooth is definitely a possibility, and it's something that heterogeneously would work. An iPhone would be able to connect with Bluetooth to an Android phone with a little bit of hackery and pass messages through that communication channel. But the problem with that is Bluetooth is 5 or 10 meters range, and if somebody's stuck under a building or under rubble, you need something a little wider to be able to get that connection made. And so really Wi-Fi is the best option that we can find at the moment for the phones to use, but it really requires some of the phones to be able to broadcast their services as an ad hoc network, or as even a structured Wi-Fi hotspot, like some of the Google phones can, and that sort of thing. So that's currently the biggest technical challenge that still remains, is how to make those connections and just notify one another that the service on both phones is running and there's information that has to be passed. If you can get that initial connection, then they can get closer and then do the Bluetooth exchange, but that initial connection is the biggest road bump at the moment.
All right, thanks.